Hello friends, my name is Sushil Pandey. Welcome to my networking video series. Today topic is network essential books. In this part, we will study identifying the IP version 4 addressing scheme and identifying the IP version 6 addressing scheme. Let's start network addressing scheme.
Network addressing schemes. A network is similar to a residential area where each house has a unique address, which enables its identification. Similarly, on a network, each node needs to have a unique address for the purpose of identification so that packets reach the correct node. The address allocated to each node on a network is known as an internet address, or an IP address. This is a unique address that allows nodes to connect and communicate over a network. Identifying the IPv4 addressing scheme. An IP address is a unique number that identifies a resource in a network. This can be explained in the context of the postal system. The postal address on a letter has the complete address of the receiver, including the house number, street name and number, city, and state. Using this address, the postal system identifies the exact house or office for delivering the letter. Serving a purpose similar to that of a postal address, an IP address uniquely identifies a resource on a network and allows nodes to connect and communicate over a network. Identifying IP address classes. IPv4 address classes are classifications of network addresses based on their network IDs. You can determine the range of octets allotted to a network ID using IPv4 address classes. The octets allocated for the network ID of an IPv4 address determine whether the network is large or small. If you increase the octets allocated for a network ID, the number of hosts that can be connected to the physical network decreases. Conversely, if you decrease the octets allocated for the network ID, the number of hosts that can be connected to the network increases. To determine the total number of hosts that you can connect using a particular class, you should use Class A. Class A IPv4 addresses are used for large networks that comprise many hosts and devices, such as network printers and routers. The following figure displays the structure of a Class A IPv4 address. The structure of a Class A IPv4 address. In Class A, the first octet is used as the network ID, and the other three octets are used as host IDs. The first bit of the first octet is used as the network ID and is reserved as 0. Therefore, it cannot be used. As a result, the number of networks included in a Class A address is 126.27.2. The value of the first octet for Class A ranges from 0 through 126. You can allocate the other three octets to hosts that need to be connected over a network. As a result, the maximum number of hosts that can be included on a single network with a Class A IPv4 address is 16,777,214, 224.2, which can also be denoted as 255x255x255, 2. The number 127 cannot be used for assigning network IDs because it is used for troubleshooting and testing network connectivity. It is also known as a loopback address. Class B. Class B IPv4 addresses are used for relatively smaller networks than Class A addresses. The following figure displays the structure of a Class B IPv4 address. The structure of a Class B IPv4 address. The first two octets in Class B addresses are reserved for the network ID and the last two octets are reserved for the host ID. As a result, the number of network bits in this case is 8 * 2 = 16. However, all the 16 bits are not used for calculating the number of networks. This is for the reason that the first 2 bits of the first octet of a Class B address are always reserved as 10. This means that a Class B address will always start with binary numbers 10 as they are fixed. Therefore, of the total 16 bits, only 14 bits can be used for creating network IDs. This results in reducing the total number of networks that can be included in a Class B address, which is 16,382, 214.2. The value of the first octet for Class B ranges from 128 through 191. As the last 2 octets in a Class B address are reserved for host IDs, the maximum number of hosts that can be included on a Class B network is 65,534, 216.2. Class C. Class C IPv4 addresses are used for small-scale networks. The following figure displays the structure of a Class C IPv4 address. The structure of a Class C IPv4 address. In Class C IPv4 addresses, the first 3 octets are reserved for assigning the network ID and only the last octet denotes the host ID. This makes 8 * 3 = 24 network bits. However, all the 24 bits are not used for calculating the number of networks. In Class C addresses, the first 3 bits of the first octet are always reserved as 110. This causes Class C addresses to start with 110, which is fixed. Therefore, of the total 24 bits, only 21 bits can be used for creating network IDs. This results in reducing the total number of networks that can be included in a Class C address, which is 2,097,150, 221.2. The value of the first octet for Class C ranges from 192 through 223. The last octet of a Class C address is reserved for host IDs. As a result, this class supports 254.28.2 host connections, which makes it suitable only for smaller networks. The following table displays the total number of usable networks and hosts in classes A, B, and C. Usable networks and hosts in classes A, B, and C. Class D. The entire range of Class D IPv4 addresses is reserved. As a result, Class D addresses are not available for allocating a network or host ID. The first 4-bit values of this class are reserved as 1110. Class D IPv4 addressing is used for multicasting, which is the method of transmitting data to a select group of hosts over a network. Multicasting helps to save network bandwidth because instead of sending data to all the hosts on a network, the data is directly sent to a limited number of hosts. This practice reduces traffic load on a network and helps to prevent network congestion. Identifying reserved IPv4 addresses. IPv4 addresses are reserved on the basis of their usability in a network. Networks are categorized as private and public. Private networks are not accessible through the internet. Moreover, hosts on private networks cannot access the internet or hosts outside the private network. However, a public network allows all types of users to connect to it. You can connect to a public network through the internet, which is also a public network. As per specifications, reserved IPv4 addresses are suitable for organizations that require limited or no access to the internet. IANA provides the following 3 sets of blocks or ranges reserved for assigning private network addresses. 10.0.0.0.0 to 10.25 172.168.155.255 for Class A. 172.16.0.0 to 172.31.255.255 for Class B. 192.168.0.0 to 192.168.255.255 for Class C. These blocks of reserved IPv4 addresses cannot be used to assign IPv4 addresses outside a private network address space. To assign public IPv4 addresses to hosts, the network addresses should be outside the blocks assigned for private networks. Similarly, there are IPv4 address ranges that are assigned on lease by the ISP. The following IPv4 address ranges are reserved for public networks: 1.0.0.0 to 9.255.255.255 and 1.0.0.0 to 126.255.255.255 for Class A. 128.0.0.0 to 172.15.255.255 and 172.32.0.0 to 191.255.255.255 for Class B. 192.0.0.0 to 192.167.255.255 and 192.169.0.0 to 223.255.255.255 for Class C. Advantages of reserved private addresses. Private networks enable optimized utilization of IPv4 addresses. The IPv4 addresses assigned to the hosts on a private network need to be unique only within the network. Some of the main advantages of reserved IPv4 addressing are: categorizing IP addresses based on communication flow. In a network, the data sent to a destination can be directed in different ways. This means that the flow of communication of data packets on a network can be one-to-one, one-to-many, or one-to-all. On the basis of the manner in which communication occurs, IPv4 addresses of data packets are categorized into the following types. Unicast address is the IP address that points to a single node. In unicast data transmission, the flow of data packets is diverted using an IP address, which points to a single destination or node. Unicast data transmission occurs from point to point, which means it occurs from one source to one destination. For example, 192.168.10.1 is a unicast address. The following figure displays unicast data transmission. Broadcast address is the IP address that points to all nodes in a network. Each network has a defined broadcast address, which is formed by adding all ones with the network ID of the network. In broadcast data transmission, the flow of data packets is diverted using an IP address, which points to all the nodes of a network. For example, 192.168.1.255 is the broadcast address of the 192.168.1.0 network. The following figure displays broadcast data transmission. Multicast address is the IP address that points to specific nodes in a network. A multicast IP address is defined when data packets are to be sent from one node to multiple nodes in a network. To initiate multicast data transmission, a Class D IP address is used. Next, a multicast group is created and the network nodes are made members of this group. For transmission, the server sends a packet to a single IP address, which is the multicast IP address, such as 230.1.1.1, and all the nodes, which are members of the multicast group, receive the packets. The following figure displays multicast data transmission. Multicast data transmission. Identifying reserved Internet Protocol addresses. A number of IP addresses are reserved and used for performing predetermined tasks, such as identification of networks and subnet masks. The reservation of IP addresses is based on certain rules and standards for IP addressing. The base rule of IP addressing standards is that the host portion of the IP address cannot be set to all binary zeros or all binary ones. Therefore, this rule compels you to use specific IP addresses to identify special types of IP addresses, such as a network address. IP addresses used for special identification are of the following types: network addresses, broadcast addresses, special case source addresses, loopback addresses, subnet masks. Implementing subnetting. The growth of the Internet has presented innumerable opportunities as well as challenges. One of the key challenges is the assignment of IP addresses to the ever-growing population of networks and hosts. The most common method of assigning IP addresses is the classful method. In this method, IP addresses are assigned based on the IP address classes, Class A, Class B, and Class C. However, beyond a limit, 32-bit IP addresses cannot be assigned to networks or hosts. To overcome this problem of limited availability of unique IP addresses, the concept of subnetting was introduced. Understanding classless interdomain routing. Classless interdomain routing, CIDR, is an IP addressing scheme that allows for efficient management of IP addresses. A brief overview of subnetting and problems resulting from it will help you understand why CIDR was required. Subnetting helped in breaking up a classful network into multiple subnetworks. However, it also led to the problem of ever-increasing networks, which in turn resulted in overburdened routing tables. This happened because subnetting allowed more and more networks, and these new networks needed to be advertised in the routing tables. Understanding Internet Protocol address assignment. Each device on a network should have a unique IP address for communication. However, for communication over a network, clients also require additional IP configuration settings, such as subnet mask is used to define the network and host portion of an IP address. Default gateway is used to define the address of the router, which is responsible for routing the packets outside the network. Domain name server address is used to static assignment. Static assignment of IP addresses is a manual way of assigning IP addresses to the devices in a network. However, it is difficult to adopt this method of IP address assignment when there are a large number of computers. This is because it takes a lot of time and sometimes becomes a tedious task if an IP address requires a change. DHCP. With the increasing number of desktops in a network, the task of assigning and managing IP addresses manually becomes difficult and prone to errors. Manual configuration of IP addresses can also result in allocation of invalid IP addresses. To address these issues, a service called DHCP is used. Consider a rapidly developing organization where automatic private IP addressing. API is a feature of Windows operating systems. It is an automatic IP assignment procedure that takes charge of IP address assignment when a network device does not have a manual IP address and is even not able to contact a DHCP server. This feature allows a client to have an automatic IP address from the IP network of 169.254.0.0/16. Identifying the IPv6 addressing scheme. The Internet has grown tremendously in the last decade. The use of TCP/IP has increased with time. This has resulted in a shortage of IPv4 addresses. Therefore, IPv4 has been redesigned and the new version, known as IPv6, has been released. An IPv6 address uses a 128-bit address scheme as compared to a 32-bit address scheme used in IPv4. This allows you to have 2,128 unique IP addresses as compared to the 232 unique IP addresses provided by IPv4. And IPv6. Identifying the benefits of IPv6. IPv6 is beneficial in the following ways. Larger address space. The main benefit of IPv6 is its large address space. IPv6 provides 128-bit addresses, which creates a pool of addresses that is virtually inexhaustible. Stateless auto-configuration. The host can configure itself with the address and other information without any server. More efficient packet headers. IPv6 header space is simpler than that of IPv4. Routers analyze an IPv6 packet faster than an IPv4 packet because of the following reasons. Fewer header fields. Completely discarded header checksums. Due to efficient packet headers, IPv6 saves router resources and increases network performance. Identifying the IPv6 address format. IPv6 addresses follow hexadecimal format. It uses 128-bit hexadecimal notation called the colon hexadecimal notation. This address space supports a much wider address space than IPv4. The hexadecimal addresses are 16-bit groups, separated by colons. The following figure displays the format of a typical IPv6 address. An IPv6 address. The following four formats are used to express IPv6 addresses. Usual format. Usually, IPv6 addresses are expressed as hexadecimal numbers. There are 8 fields, each denoting a